Hello Year 5, we are back with another fractions video today, and I have got the question for you of, I've ordered 2 large pizzas from Domino's. I do like a Domino's. And one of them I've cut into quarters, or I've cut into 4, and I've shown you that here. The other large pizza has been cut into 8. Now I'm asking you, what if someone offered you 1/4 of a pizza or 2/8 of a pizza, a large pizza? What would your response be? Pause the video and have a think. So they've offered you 1/4 of a large pizza or 2/8 of a large pizza. Now the large pizza tells us that these pizzas are the same size. They are both large. They've just been cut into a different number of pieces. And you should have been able to think, I know that 1/4 is equivalent to 2/8. So we could write it as 1/4 is actually equivalent to 2/8. So if someone's asking me if I would prefer or which one I would want, I would say, doesn't matter. They are both the same. I would get the same amount of pizza, okay? That was just a little bit of a warm-up to get us thinking about the equivalent fractions we did yesterday. And now we're going to move on to our work today. Now, I want you to have a look at the fractions on my whiteboard. And I'm asking you, can you name all the different types of fractions on my board? Because as you can see, they're all a little bit different. The numerator, the denominators are different, and some are written completely differently that might be new to you. So you need to tell me which of the fractions on the board are a unit fraction, which is a non-unit fraction, which is an improper fraction, and then the last one is a mixed number fraction. Now, a couple of those might be new to you, but we definitely looked at unit and non-unit on Monday. So pause the video now, try and pick which one is which. Okay, should have had a chance to think about that now. So we know from Monday that unit fractions have a numerator of 1. So I know straight away my 1/6 over here is the unit fraction. I'll say unit like that. The second type we'd looked at on Monday was a non-unit fraction. So of the fractions on my board, which is our non-unit fraction? And it could be this one or this one. But I'm going to tell you that it is actually the 2/5. This is a non-unit fraction because the numerator is smaller than the denominator, and that is where we need to start thinking about improper fractions, which we're learning about today, because 7/4, can you see that 7 is bigger than 4? Now we know that the denominator tells us the number of parts in the whole. So how can you have more than 4 if something is split into 4? And that is what we are going to look at today. So 7/4 is an improper fraction, like that. Which leaves the last one. Can you remember which one it was? That's right, it was a mixed number or a mixed fraction. And can you see this one down here has a 1 and a 1/3 in sort of the answer written down. So it's a mixture of 2. You've got whole numbers and fractions. So that is how we remember that this fractions written like this are called mixed numbers or mixed fractions. Okay? So we're going to look a little bit more into that now. 7/4 is an improper fraction because the numerator is bigger than the denominator. Now I'm going to show you what 7/4 would look like, and I'm going to use multi-link cubes to help me today. So as you can probably guess, the numerator still tells us the number of parts. So I need 7 because that is still telling us that there are 7 parts in use, or 7 things in our question. 1, 2, 3, 4, 5, 6, and 7. I've got my 7 parts here. Now, we still need to look at the denominator to help us with this question. So you could say I have 7/4 here, which is what this fraction is telling us, isn't it? 7/4. And I've got 7, all of the same size, all equal, same colour as well because we're using the multi-link cubes, but I've got 7/4. And the quarters tells us that these can go into groups of wholes with 4 in each. So let me make my wholes. So we know that 4 pieces or 4 parts make a whole when we're using quarters. So there I've got 1 whole. Can you see? Because I've got 1, 2, 3, 4. But there's these 3 left over. And can I make a whole with just 3 quarters? And the answer is no, you can't. It won't be whole because you need 4 quarters to make a whole. So I've got 7 quarters here, but I can also say it that I've got 1 whole, because I've got 1 whole here. And how many quarters are left over? How many quarters don't make a whole? That's right, we've got 1, 2, 3. So I could write 7 quarters as 1 and 3 quarters. And this is the improper fraction, and this is the mixed number. Okay, that is what we're looking at today, the relationship between improper fractions and mixed numbers. All okay with that so far? You could also show this on a number line, so I'm going to move my cubes out of the way. If I wanted to show 7 quarters on a number line, if I draw my number line up here, just like that. So I've got 7. So I need to have 7 sections on my number line. Let's just move that out of the way. So 1, 4, 5, 6, 7. Can you all see? And we're imagining that those are even. It's quite hard with a whiteboard and a pen. And just like we looked on Monday, we can count up in fractions, just like we would in number sequences. So here is our 0. Next would be 1 quarter, followed by 2 quarters, followed by 3 quarters, followed by 4 quarters. And 4 quarters can also be explained or shown as 1. Let's carry on counting up in our parts, if you like. So 4 quarters would be 5 quarters, and then 6 quarters, and finally 7 quarters, which is the one what they're wanting to show. Now, let's look on the bottom here. So 4 quarters we can say is 1. What about 2 quarters? How else can we say 2 quarters that we've looked at so far this week? And that's right, we can also call it a half, like that. So if we're at 1 here, add a quarter, add 2 quarters, what have I made here? What mixed number could I write here for 6 quarters? And I could put 1 1/2 because we've added on another 2 quarters, and we know that 2 quarters equals a half, so we can call it 1 1/2. But we had 7 quarters, so 1 1/2, add another quarter, or 6 quarters, add 1 more quarter, will give us that answer again that we had of 1 3 quarters. 7 quarters and 1 3 quarters are equivalent. They are the same. They mean the same thing. They're just written in 2 different formats, okay? Or, okay. For 7 quarters, if I draw some squares and I split them into 4, how am I going to show 7 quarters like this? Well, I know that I can go 1, 2, 3, 4. But we've got 7, so I'm going to draw another square. Making sure they're accurate, again, is quite hard on a whiteboard, but imagine for me that these are equal. I need another whole, and I've got 1, 2, 3, 4, and then I'm going to go 5, 6, 7, but I don't have that 8th to complete that one. This is another way of showing we've got 1 whole and 3 quarters. Can you all see that? The relationship that 7 quarters, you've got 7 of 7 quarters, or 7 cubes like we started off with, can also be shown as 1 whole and 3 quarters left over. Okay? Right, new example for you. What about 9 halves? 9 halves, and we know that's halves because there's 2 on the bottom. If you split anything into 2, you have halved it, haven't you? So I've got 9 halves here. Let's get more multi-link cubes. So I've got 9 halves. So I've got 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, and 9. My 9 parts here. So questions will ask you, what is 9 halves as a mixed number? So using the multi-link cubes, how are we going to work out what 9 halves is as a mixed number? And we need to think, how many parts make a whole if we're working with halves? And we know the answer is 2. So let's like that. I've made 1 hole there. And I can make another hole, just like that. And I can make another hole. And another one. But I've only got 1 left. That will not make a whole. So our mixed number, remember, is how many holes we can make altogether and the fraction that is left over. So my 9 halves as a mixed number is going to be 1, 2, 3, 4 wholes and 1 half, which is written as 1/2, 1 half. 4 and a half. 9 halves is equivalent to 4 and a half. Okay, all happy so far. We can also do that on a number line. So let's draw our number line. We're working in halves this time, so we could go to half. Like this. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. That is quite even. I'm quite impressed with myself for that. So 0 is at this end of our number line. And then we're going to count up in halves. So we're going to go half, 2 halves, or what could that also be called? 1 whole, that's right. Then we're going to go 3 halves, 4 halves. Can we say that a different way? If we've got 4 halves, 4 lots, we could also call that is 2 wholes, because 4 halves make 2 wholes. And then keep counting up, 5 halves, 6 halves, 7 halves, 8 halves, and 9 halves. So, oh, look, 2 and then 4. So what's 6 halves going to be? 6 halves is going to be 3 wholes. And then using our 2 times table knowledge, 8 halves is going to be 4, isn't it? And then we've got 1 half left over because we had 9 halves at the beginning. So that's where our 4 and a half comes from, because we could have 4 wholes and a half left over. Can you see how that's represented as a number line as well? Good. I'm going to give you some to do on your own. 17 sixths. I'd like you to pause the video and have a go on your own at working out 17 sixths as a mixed number. So this is the improper, and then I want you to tell me the mixed number. Pause the video now and have a go. We are working in sixths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, so good at us. Nearly did a really good estimate there and got 17. Right, 17. The denominator is important. It tells us that we are working in sixths. So how many parts will be in 1 whole if we're working with sixths? And the answer is 6. So I need to think, how many wholes or how many groups of 6 can I make from 16? 4, 5. These are quite tricky, actually. 6. That's 1 whole there. Do you agree? 1, 2, 3, 4, 5, and 6. 1 whole there. Right, can I make another one? 1, 2, 3, 4, 5, 6. Like that. And then can I make, I've got 1, 2, 3, 4. I've only got 5. So have I made a whole if I've only got 5 sixths? And the answer is no. So 17 sixths as a mixed number is 1, 2 wholes, 2 wholes, And how many left over? What fraction left over? 1, 2, 3, 4, 5. The denominator stays the same, and it's 2 5/6, like that. Did you get that answer? Well done if you did. We're going to do 2 more together, and then you're going to have a go at your worksheet. I'm going to give you 18/8. Pause the video, have a go on your own, and then check back for the answer. Got my 18 parts here, and how many of these parts make a whole? Look at our improper fraction. The denominator is an 8, so we're looking at eighths. So I need to put 8 of these to make a whole. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Oh, nearly went over then. 8. There's one of my holes there. Can I make another one? 1, 2, 3, 4, 5, 6, 7, 8. I can make another hole there, but it is an improper fraction. It doesn't go exactly. So 18/8 as a mixed number, I can say I've got 1, 2 holes, and what fraction left over? 2/8, because we keep the denominator the same. So 18/8 is the same as 2 2/8, just like that. And well done if you got that answer. 22/5. 22/5. Now, have a go at this. Pause the video. See if you can work out the mixed number. And should have had a go. Right. I'm not going to use the cubes this time because I think I've shown what I'm doing or what you're trying to do when you're working out converting improper fractions to mixed numbers. I'm going to show you using your mental knowledge, your mental multiplication facts. So if the denominator is 5, you are thinking, how many groups of 5 can I make from 22? And using my 5 times tables, counting up in 5s, 5, 10, 15, 20. I know I can get 4 wholes because 5 times 4 is 20. But that's not all of my pieces because it was 22. That just tells me I've got 4 wholes and 2/5 left over, okay? And when we add it back up, we can look, if I think 5 times 4, I can like multiply, do 5 times 4, that's 20, and add on the 2 at the top, that does give me 22. So I know I haven't lost any fifths along the way. And I've got a final question to get you thinking today before you go off to do your worksheet. 18, say triangles, is the same as triangle 2 over triangle. Now you're probably thinking Miss Smart has lost the plot, but no. This question wants you to work out the value of the number that the triangle is representing. And I would look at this question and think, right, they've given me an improper fraction here and a mixed number here. What I would think is, my answer has 2 parts left over, 2 over something. We're not quite sure yet what that is. I would look at the total number of parts on this side and see, right, 18. I'm going to do 18 take away 2, which will give me 16. And then using my times table knowledge, what times table does 16 come in? What could I place that with? And I'm thinking, 4 times 4 is 16. So let's try it with quarters. If we said 18 quarters, let's jot that under here because we're not sure yet because 16 could go in numerous times tables. 18 quarters, what would that be as a mixed number? What would that be as a mixed number? And I'm going to think, right, 4 times 4 is 16, so that puts a 4 there. And yeah, if I've got 4 times 4 is 16, but I needed 18, that would leave me with 2 quarters left over. And can you see that I've got a 4 in every single place there was a triangle? And because there's only one shape, they all have to be the same. So the value of the triangle is 4, like that. You do have some questions like this on your sheet today, so I just wanted to go through how I would work it out to help you before you set off. But if you're finding this a little bit hard, it might be good to start your maths session today with a bit of TT Rockstars to practice times tables. If not, have a go at the worksheet, which is all about converting from improper fractions to mixed numbers. And best of luck. See you tomorrow.